One reaction of ethers that is potentially dangerous is that of autooxidation, in which an ether reacts with a peroxide and oxygen to produce a potentially explosive ether peroxide. This mechanism begins with an initiation step in which the peroxide breaks into two reactive radicals. These radicals then abstract an H atom next to oxygen on the ether in a regioselective fashion. The new carbon radical then reacts with atmospheric oxygen to give a new peroxide radical. This then abstracts an H atom from another molecule of the ether. This propagation step gives the peroxide product as well as a new carbon radical that is able to cycle through the whole process again. The reaction is initiated by the weak oxygen-oxygen bond being cleaved in a homolytic manner to give two reactive oxygen-based radicals. The reactive oxygen radical then abstracts a hydrogen atom from the ether substrate in a regioselective way to give a carbon-based radical. This is stabilized through electron donation from the adjacent oxygen. The C radical then couples with molecular oxygen from the atmosphere to produce a new peroxide radical in what is essentially a propagation step. Finally, to complete the formation of the ether peroxide product, a hydrogen is abstracted from a second molecule of the ether. This again occurs in a regioselective way to give the peroxide product. The carbon-based radical that is also generated in this propagation step is able to be recycled through a new iteration of the same overall mechanism. In summary, exposure of ethers to peroxides and atmospheric oxygen causes the ether to be converted to potentially dangerous ether peroxides. The process involves the typical radical-based bond breaking and bond-forming events along the way to the peroxide product.